Introduction to Mathematics for Computing. Topic 2, Sets and Operations, Part 1. In this session we're going to introduce a branch of mathematics called set theory, and as the name suggests, set theory is about mathematical objects called sets. So we'll kick off with a description of what a set is. Following that we'll move on to look at the idea of a subset, and here we'll be looking at the relationship between sets in which we can consider one set as being contained in some way within another set. Following that we'll have a look at some set operations. The idea here is that we can take two sets and combine them in some way to produce a third set. And finally we'll end with a summary of the topics covered in this session. So let's move on and have a look at what are sets. Well, we can think of a set as a collection of objects, a collection of things. And the objects in the collection are called elements or members of the set. So let's have a look at some examples then. The set of all students registered at NCI. The set of all molecules of oxygen in this room. The set of all computers and chairs in SCO2. In each of the cases given here, we're dealing with physical objects. So the first example is about people, the second example about molecules, and the third example about computers and chairs. So in each of these examples, it's physical objects we're dealing with. Sets, and the idea of a set, is a very broad concept, and we can actually have members in a set that don't have to be physical objects. And in mathematics, generally, the objects won't be physical. So we'll be dealing with more abstract ideas such as numbers, which will form elements of a given set. Okay, so let's investigate this topic in a bit more detail now. Okay, let's have a look at this idea of sets in a bit more detail, and we'll illustrate some of the ideas through the means of an example. So let's consider some objects. Okay, let me start off maybe considering a box, and let me also consider the number 1 and a person. Okay, so we have 3 objects here, and let's see if we can actually form some sets using these objects. So one way of thinking of a set is as a container of things. So as a means to illustrate this idea of a container, let me draw a boundary. Okay, and within this boundary I'm going to place some objects. Okay, so the objects are contained within the boundary, and it's going to be a collection of objects within this boundary. So let me put in the first one a box and the number 1. Okay, so we have 2 objects sitting within this collection. Let me form another collection then. So again, let me just create a boundary here that's going to act as a container for the objects, and in the second one I'm going to place a person, this person here, and the box. Okay, so in this case we've got 2 sets. The first set contains 2 objects, the second set contains 2 objects also. And we can see in the first set that the types of objects that a set contains don't have to be the same type. So we've got a box, which could be considered a physical object, and we've got the number 1, which is more of an abstract conceptual object. Both of those objects can still sit within the same sector. Okay, so we've seen that this idea of sets really tries to encompass a broad concept, and we're dealing with mathematical objects that are used to collect together other objects. Okay, so let's just write that down then. Sets. They are abstract mathematical objects that are used to collect together other objects. Okay, so we have this idea of a collection of objects or a collection of things. Now, let's have a look at some criticisms of that description of what a set is. The first one we might have is, well, how do we know whether a particular object should be in a set or not? So we want to extend out this description of a set. So rather than saying that it's just a collection of objects, we want to introduce some terminology and say it's a collection of well-defined objects. A collection of well-defined objects. And let's have a look at what we mean by saying that something is well-defined. Okay, so what exactly are we trying to get across with this idea of something being well-defined? Well, really the idea is that we don't want to introduce ambiguity. So if we have objects, we'd like to be able to describe those objects in an unambiguous manner. Okay, so in that way, there should be no dispute about whether a particular object is a member or an element of a set or not. So this idea of well-defined, essentially what we're saying is that the objects should be described in an unambiguous manner. Okay, any other criticisms or any other queries that we might have about sets? One that comes to mind is regarding the number of elements that a set may have. So a question might be, how many elements can a set have? Is there a maximum number of elements a set can have? Or is there a minimum number of elements a set can have? Okay, so a question then. How many elements can a set contain? Okay, so is there a max? And also, is there a min? Okay, so the answer to these questions is that the minimum number of elements a set can contain is 0, so we can have a set with no elements, and the maximum number a set can contain is infinite. Okay, so we go from 0, the minimum number, up to an infinite number of elements in a set. And also when we're dealing with this concept of infinity, we'll see that we need to investigate it further. We have the idea of a set containing a countably infinite number of elements, or also it may contain what's known as an uncountably infinite number of elements. So later today we'll have a look at this idea of how many elements are in a set. That general idea is called the cardinality of a set, and as I said, we can go from 0 elements all the way up to an infinite number of elements, and within that idea of infinity we actually have different types of infinity that need to be considered also.